Ya, Assalamualaikum warahmatullahi wabarakatuh. I am Hairul Azwani with Aziman, with my partner in Group 5, Fauziyah Abdulsalam Hammid. Both the project Advanced Microprocessor Systems. Choose the title Friction Voice Detection Utilizing ARM Cortex-M CMC's NN. Keyword spotting KWS device. I use spreadly like Apple Series, Microsoft Cortana, Google Assistant, and Amazon Alexa. KWS continues to detect the redetermined keyword correctly. This project concept is selective one a device to be able to detect certain keywords in user utterance. This project development, we are using STM32F746G-Disco Discovery Board, which is embedded with the MEMS microphone, which is input and 4.3-inch WQ VGA TFT LCD display with capacitive touchscreen the output. Methodology: keyword spotting system require the low power consumption. For this Cortex M7, we use suit the requirement with low power and high frequency up to 270 MHz. The KWS process involves three major processes, namely voice command, processing, and response. The digital microphone, which is embedded in the microcontroller, are used to record the command given by the user. Then, the Sigma data converter converts the audio signal into a pulse density modulator (PDM). After that, it is processed by decimeter to be converted into pulse code modulator (PCM). Voice activation with keyword spotting use a processing pipeline. It extracts very frequency domain features from an audio input signal. It uses probability in prediction the input signal to compare the level used in neural network. In a neural network, two operations are executed in order to decode the command. Start by fetching speech feature and then map it via neural network supporting function which has training data which predetermine desired output. The data is fed through the neural network function and convoluted through the network nodes to train an adjust node weight accordingly. After that, the resultant command is sent back to execute the desired function that correlated with the voice command. KWS consists of a feature extractor and neural network-based classifier. First, the components of input-output sample are identified, extracting the feature called male frequency spectral coefficient (MFCC). The MFCC gives an accurate representation of short-term power spectrum of sound. The expected speech feature metric is fed into the neural network, which is responsible to determining what keyword the input sound belongs to. This is the neural network using DSCNN. What is neural network using DSCNN? For this project, we implement the DSCNN, which is depth-wise separable convolution neural network. The architecture neural network has 5 layers. The first layer is regular convolution layer, and the other 4 layers is combinational of deep-wise separable convolution and point-wise convolution function. Next, we go to the video of programming and demo, which is shown by my friend.
The second part for our project, we will show you how to operate the board using C and C++ programming languages. Our tasks in this project to give the neural network voice commands, and it works to detect for keywords yes or no. As we see here, the file has gear symbol is driver file called dependencies like audio, PSP, LCD, and SRAM. The code to function, we need the dependencies file. Our project exists inside this file TensorFlow. The basic function uses TensorFlow is software from Google. They has packages in which they do training for network, a neural network, and database, and they get neural network that can detect a keyword yes or no. Inside this file we have micro file, then we have main project. Inside micro file is the code for our project. Main project divided to audio provider, you can see here, is function takes the voice from microphone and transfer to sample 0 or 1. Second file, command response, is called every time potential command has been identified from this file. You can change the color of screen our board or the line for screen. In micro features, we have micro features generator. Use fast Fourier transform to create spectrum from audio, and then model setting. In this file, the model outputs probability score for each category. It understands yes, no, unknown, and silence. The probability score indicates whether the audio is likely to belong at the category. Then we go to next file, model.cc has value, has large amount of weight by hexa value. In neural network we have input and weight. Each input is associated with weight distributed on each node, related rather than having a value. This value is weight of each node. The sound enters it get him proceed, and then output is yes or no. The main model for our project has a number of nodes. We can see here this number node for our project 18712. So we have a neural network. The main one for determine input and output. Second has feature for no keyword, and third has feature for yes keyword. Both of them has a certain value and certain weight. And from file main function we can call all this file as mentioned before. Then by using file main.cc we can call main function. This file is entry point for MPED program. which can run the machine learning model using TensorFlow Lite for microcontrollers. We know that in C program we need compile, build and run. Now we want to do compile code, press on clean build. It will begin from 0% until 100% for all files. So for the screen to work, we need C program, and for microphone to work, we need drivers file. We wait until finish compile to test our board. No,
Yes.
no,
Yes.
Thanks for watching from our group. Please like and share. Thank you.